Hello, everybody. We're going to quickly talk about minerals. And we see the mineral baby. There are other pictures of the mineral baby varying between 3.2 to 3.9 million pounds of minerals that are quote unquote needed by every American. So this is in your lifetime. And I would say their lifetime, not his or her lifetime. But so this varies. Don't The question I have is I look at this and I go, what does need mean? Is it a need? Is it a want? Or, because we essentially don't need some of these, or at least not in this excessive amounts, because we don't need to drive the cars that we drive. We don't need to do a lot of the things that we do. So it's just something to think about as we go through this and learn what minerals are. I wonder where they get this data. Some of it is essential. Some of it we do need. Our bodies need in order to survive. We need to consume it. But I wonder where they get this information from, and if they're just taking sort of what the average American um, person living in the United States uses in their lifetime, and would these numbers vary for people in other countries, and why? So, just something to think about. So, what on earth is a mineral? Well, first of all, it is on Earth. That's where we find them, and out in the solar system and universe as well. But these are what we're calling found on Earth. They are naturally occurring. They are not human made. Okay, so they occur naturally. They are solids. This would be sort of in their average state and at room temperature. They are not a liquid. They are not a gas. They are not a plasma. So this would come up with water is sometimes often a question, or ice is a question. Is ice a mineral or not? And some people say yes, it is. Some people say no, it's not, because ice occurs as a liquid most naturally on the Earth's surface. So then, inorganic, which means they are not made by living things or the remains of living things. Okay, so a tree is not a mineral. Just fossilized bones would not be a mineral. Anything that contains the remains of living things. Coal would not be a mineral that we burn, because that's the remains of plants from millions of years ago. So those are three of the five. They occur naturally. They are solid. They are inorganic. So what is a mineral? A mineral is a naturally occurring inorganic solid. I should probably reverse that order when I make this. A naturally occurring inorganic solid. They have a definite chemical composition. So that means if I go into Fred's backyard and I dig up halite, which is rock salt, to where we get salt from. This is an example of halite here. We purify it, we clean it. Um, but if that is the case, salt, if it's rock salt or halite, if I dig it up in Fred's backyard and then I fly across the planet and I dig it up in somebody's backyard over in Australia, and they're both halite, then they are both going to be NaCl, sodium and chlorine. That is the definite chemical composition. So all minerals, no matter where you dig it up, no matter where you find it, no matter where it's sitting on the ground, if it is a type of mineral, it will have the same chemical composition, or at least a very close chemical composition. There's a window there that it can be to be the same mineral. Okay. And number five, so we've got four so far. They are naturally occurring inorganic solid. They have a definite chemical composition, and they have a crystal structure due to the arrangement of their atoms. So you've got a long story again here about halite. And you can see halite is sodium and chlorine. And the way the atoms are attracted to each other, these ions, these charged atoms, the way they're attracted to each other creates a cubic pattern. So if we do not create a naturally occurring mineral, but if we actually try and create a mineral or the version of a mineral, we take salt and we pour it in water and then we dissolve it and then we evaporate the water slowly, we'll have these crystals form. Salt under the microscope has this kind of cubic pattern. It's super cool. And so that's because of the way that the atoms, I've told you everything comes back to electrons on this planet, is that the way these atoms bond with each other with these electrons is they form a cubic pattern. Here's another look at the crystal structure, just different crystal structures you could have, isometric up to trigonal. And sometimes they're hard to see in the minerals, I'll be honest. Like, you can look at the mineral and go, "Oh, what is that crystal structure?" But if you get it under a microscope, or if you look at um, some really, clear pieces of it broken and fractured along the lines of the crystal structure, you can see these patterns. And these patterns all have to do with the way the atoms are attracted to each other and how they bond. And so these are the crystal structures. So that's number 5. So if we go back up again, we got 5 properties of minerals that we're going to know. They occur naturally, they are inorganic, they are solids. They are naturally occurring inorganic solid with a definite chemical composition and a crystal structure. 1 through 5. Some general facts about minerals, there are about 5,400 or so. It changes. We get 30 to 50 new per year, and we take away a couple every year. A few are native elements. They're made of only one element, like gold, copper, sulfur, graphite. Those are all elements on the periodic table of elements, but they're also minerals. But most minerals are compounds. The silicate group is the most common. They contain silicon and oxygen, which is no surprise because it's the most abundant elements on the Earth's surface. And then other important groups are oxides, carbonates, and sulfides. So if we look here, here's an example of some of them, some classifications. You don't need to memorize these, but it's good to know um, what their sort of their basic. These are going to be included in their chemical formula. So sulfides contain sulfur, sulfates contain sulfur and oxygen, halides contain chlorine or fluorine, carbonates carbon and oxygen. And then our native elements, our silicates or SiO2s. So these are some examples of them. Just so you know, they have a definite chemical composition, right? So these groups will contain those. Common rock forming minerals. So when we pick up rocks, rocks are made of minerals. That's the difference between a rock and a mineral, right? um, we have we look at the 5 properties of a mineral, and that makes them a mineral. Now a rock could be a mixture of these. We also have rocks that are made out of the remains of living things, rocks that are just don't fit those 5 traits of all minerals, these 5 naturally occurring inorganic solids with a definite chemical composition and a crystal structure. So these elements here, these minerals here, form rocks. And then if we look at our common uses, we have lots of uses for minerals. Aluminum, beryllium, we got gemstones, fluorescent lighting, packing, wires, so many different things. Toothpaste, construction, buildings, magnets, cars, all the things that we use in our everyday lives. Minerals are coming in, and we're going to look at that and explore those and how we use minerals. And that goes back up to the mineral baby. you know what do we need, what is essential, and what do we want? And those are the questions that I always wonder about. All right, folks, hope we got good notes.